Hi everyone, welcome back to the channel. In this video, we're going to solve LeetCode problem 110, balanced binary tree. This is a very common interview question, especially for tree and recursion concepts. Let's understand it step by step. Problem understanding. We are given a binary tree, and our task is to check whether it is height balanced. Now, what does height balanced mean? A binary tree is considered balanced if for every node, the difference between the height of its left subtree and right subtree is at most 1. If this condition fails even for a single node, the tree is not balanced. Key insight. The most important thing to realize is, we need the height of left and right subtrees. We also need to know whether they are balanced. So this naturally leads us to recursion, because height of a tree depends on heights of its subtrees. Balance of a tree depends on balance of its subtrees. Let's now understand the problem better using a few examples. First example. The input tree is root equals 3, 9, 20, null, null, 15, 7. If we draw this tree, 3 is the root. 9 is on the left side, and 20 is on the right side. The node 20 has two children, 15 and 7. Now let's check the height difference. The left subtree of the root has height 1. The right subtree has height 2. The difference is 1, which is allowed. We also check every node in the tree. At each node, the height difference between left and right subtrees is never more than 1. So this tree is height balanced, and the output is true. Second example. The input tree is root equals 1, 2, 2, 3, 3, null, null, 4, 4. If you visualize this tree, you will notice that it is skewed on the left side. The left subtree keeps growing deeper, while the right subtree is much shorter. At one of the nodes, the difference between the left subtree height and the right subtree height becomes greater than 1. Because this condition fails even at a single node, the entire tree is considered not balanced. So the output for this example is false. Third example. The input tree is empty. An empty tree has no nodes, so there is no height difference to check. By definition, an empty tree is always balanced. So the output is true. In short and easy to understand. If every node in the tree has left and right subtree heights that differ by at most 1, the tree is balanced. If any node violates this rule, the tree is not balanced. In this video, we are going to understand how to solve the balanced binary tree problem using recursion. The goal is simple. We need to check whether a binary tree is height balanced. A binary tree is balanced if, for every node, the height difference between its left and right subtrees is at most 1. Let's walk through the code step by step. We start with the function isBalanced, which takes the root of the tree as input. Inside it, we define a helper function called checkHeight. This helper function does two jobs at the same time. It calculates the height of the tree and also checks whether the tree is balanced. First, we handle the base case. If the current node is null, we return 0. This means an empty tree has height 0 and is balanced. Next, we recursively calculate the height of the left subtree and store it in a variable called leftHeight. If leftHeight comes back as -1, that means the left subtree is already unbalanced. In that case, we immediately return -1 without doing any more work. Then we do the same thing for the right subtree and store the result in rightHeight. Again, if the right subtree is unbalanced, we return -1. Now comes the most important check. We compare the heights of the left and right subtrees. If the absolute difference between leftHeight and rightHeight is greater than 1, the current node is unbalanced. So we return -1. If the difference is within the allowed range, the tree rooted at this node is balanced. In that case, we return the height of the current node, which is 1 plus the maximum of the left and right subtree heights. This recursive process continues until we reach the root. Finally, in the isBalanced function, we call checkHeight on the root. If the result is not -1, it means the tree is balanced, so we return true. If the result is -1, the tree is not balanced, so we return false. The key idea here is using -1 as a signal value to indicate an unbalanced subtree. This allows us to stop unnecessary calculations early and makes the solution efficient. Now let's run the code. And all test cases ran successfully. And now, we can submit the solution. The code runs successfully and passes all test cases. This confirms that the approach is correct and efficient. That's it for this video. We solved the balanced binary tree problem using a clean recursive approach that checks height and balance in a single traversal. This pattern is very important for tree-based interview problems, so make sure you understand how the -1 signal works. If this explanation helped you, like the video and subscribe to the channel. I've attached the solution link in the description. See you in the next problem.